Hi everyone, my name is Tony Garnock-Jones and this is a lightning demo of a couple of projects I've been working on recently, Synit and SqueakPhone. Synit is an experimental operating system building on the Linux kernel but replacing most of the system daemons and the init system with a reactive object capability style design based around the syndicated actor model. Because I wanted to get away from the constraints of desktop systems, Synit initially targets mobile phones able to run PostmarketOS. So SqueakPhone is a Synit-based system running a Smalltalk virtual machine for its user interface and for the modem control software. Here you can see the system running on a Samsung Galaxy S7 on the right, and on the left I'm starting up a Pine phone running Synit. Now the user interface is still very basic. It's essentially a stock Smalltalk machine which is intended to work with a mouse and keyboard with only light customization for touchscreen support. It's early days for the user interface stuff. The on-screen keyboard is written in a couple of hundred lines of Smalltalk, and the touchscreen support treats each touch point on the screen as a separate mouse cursor. So just to quickly integrate with the existing software. Here you can see the little demo power display that I wrote, and you can see that both phones have a reasonable charge in their batteries. The first thing I want to show you about the phone itself as a phone per se is sending and receiving of SMS messages. Now the user interface is crude, but it lets you type in a phone number and a message to send. And as I send this off screen here, I'm accessing the message on my main cell phone and sending a reply. At the moment there's no special user interface for receiving SMSs at all. It just uses the standard Squeak Smalltalk debugging tools to put a display of the underlying object, the Smalltalk object, representing the received SMS message directly onto the screen for you to interact with. The next thing I want to show is the phone placing and receiving calls, and here I am dialing my main cell phone number, and after a little bit of delay you can hear the ringtone on my main cell phone, and you can see the state on the SqueakPhone display change as my other phone answers the call. And now I'm dialing back from my main phone, and here's the SqueakPhone ringing and answering the phone. The Smalltalk image itself has a VNC server in it, again written in Smalltalk, and Synit has configuration for setting up the Wi-Fi and mobile internet connectivity. So I can connect to the phone over Secure Shell and tunnel VNC through that Secure Shell link to get an interactive remote display on the development machine, so that I can use my comfortable keyboard instead of having to type on the tiny screen to do development on the phone itself. The last thing I want to show on the phone itself is a little demo of a slippy map, a tiled map type thing, reading from OpenStreetMaps, that I wrote in Smalltalk a few years back, and it's the same code from years ago, and the same code runs just unchanged on the phone. And because it's mostly stock Squeak image that I'm running, all of the standard tools are available, the browser and the workspace and all of the other Smalltalk things, the debugger and so forth, including the command shell, which is a Unix shell running within Smalltalk. And here I'm using it to run PS and just show the list of all of the processes running on the machine, and then to power off the phone. Now switching gears slightly, here is the Synit system with the SqueakPhone user interface running in Emulation on QEMU on my desktop machine, which is why you can see here there's an absurd number of CPUs in the emulated machine, but only a gigabyte of RAM. On the left, I've logged into the virtual phone over the Secure Shell, and I can do this on the real phone too, of course. It's a full Unix machine running PostmarketOS. On the right is the emulated display and emulated touchscreen running Smalltalk. Now, this is exactly bit for bit the same Smalltalk image running on this virtual machine as would run on the real phone. So you can download the image to your desktop machine, develop and use the image, and then push it back up to the phone and it'll pick up where it left off. And all of the same tools are of course available in all of these different contexts. And the last thing I want to show you about this is a taste of the reactivity of the system. I'll log into the Synit system using Secure Shell again and start displaying the system log, which is just a text file in /var/log as you'd expect. And here we see some error messages because the default configuration of Synit at the moment, because it's still in development, expects the system to be a PinePhone. And the PinePhone has an EG25 modem that needs a particular driver to be running. So let's disable this modem driver because on the emulated machine the modem doesn't exist. So the way we'll do it is to SSH in again in another window, change to the /etc/syndicate/services directory and remove the modem.pr file. And because the system is reactive, it'll immediately pick up the changes to the system configuration database and alter the supervision hierarchy, which then causes the modem driver that's complaining so loudly in the logs to shut down. And finally, I want to show you some finer grained changes. We'll disable and then re-enable the Smalltalk part of the system. Here I am editing the file /etc/syndicate/services/squeak.pr. I'm going to comment out the top line, which is the record in the database that requests that the service supervisors start up the Squeak system. When I save the file, you'll see a note in the log that the file was processed, and as I click on the phone screen, it's now inert. It won't do anything because the Smalltalk VM is no longer running. And the picture of the system at the time that I killed the service is still there because it's the system frame buffer and nothing is written into it to clear it. But if I now uncomment that require service line again and save the file again, you can see in the log entries from the Squeak service as it starts up and detects its environment, and it'll refresh the display and start responding again. The rest of the system is the same. It's a service supervision hierarchy configured by reactive monitoring of a configuration database. And there's quite a bit more to it. The whole thing is based around the syndicated actor model, which is something I've been working on for a few years now. You can learn more about Synit, about the SqueakPhone, and about the syndicated actor model at https://synit.org and syndicate-lang.org. Thanks for watching.